Welcome students. In this tutorial, we will study Routh-Hurwitz stability criteria. Routh-Hurwitz stability criteria is a tabular form method. Using it, we can determine the stability of linear systems. Here, you can see a closed loop system whose transfer function is g of s by 1 plus g of s into h of s. Now, what is characteristics equation? Characteristics equation is the denominator polynomial of this transfer function equals to 0. That is 1 plus g of s into h of s equals to 0. Now you can see here the s plane where the real axis denoted by sigma and imaginary axis denoted by j omega. This is left half plane and this is right half plane. Now what is stable system? For a linear time invariant system, as long as all poles are in this side, this left side, the system is stable, and if there is at least one pole in right half plane, then the system becomes unstable. Now what is marginally stable system? When the poles of the system exist on j omega axis and there is no pole in right half plane, the system is called marginally stable system. So if there are no poles, there are some poles on left hand plane and one or multiple poles on j omega axis and no pole in right half plane, then the system is marginally stable. If there are repeated poles on any point on this j omega axis, then the system becomes unstable. যেমন যদি এই অরিজিনে, যেহেতু অরিজিন j ওমেগা অ্যাক্সিসের উপরে রয়েছে, এই অরিজিনে যদি দুটো পোল থাকে তাহলে সিস্টেমটি আনস্টেবল হবে। বা এই j ওমেগা অ্যাক্সিসের উপরে যদি কোনো রিপিটেড কমপ্লেক্স পোল থাকে, ইমাজিনারি পোল থাকে, তাহলেও সিস্টেমটি আনস্টেবল হবে। নাও স্টেটমেন্ট অফ Routh-Hurwitz criteria. Any system can be stable if and only if all the roots of the first column have same sign, and if there is a sign change, then the number of sign changes is equal to the number of roots of the characteristics equation in the right half plane. That is একটা সিস্টেম, আমরা কোনো একটা লিনিয়ার সিস্টেমকে RH ক্রাইটেরিয়ার মাধ্যমে যখন স্টেবিলিটি তার ডিটারমাইন করব, তখন একটা ট্যাবুলার ফর্ম তৈরি হবে। সেই ট্যাবুলার ফর্মের ফার্স্ট কলামের যদি প্রত্যেকটা রুটস, যতগুলো রুটস আসবে, প্রত্যেকটা রুটসের যদি সেম সাইন থাকে, ইটস আইদার বি পজিটিভ অর নেগেটিভ, তাহলে সেই সিস্টেমটিকে আমরা স্টেবল বলতে পারবো। এবং যদি সেই ফার্স্ট কলামে যদি সাইন চেঞ্জ হয়, তাহলে কতবার সাইন চেঞ্জ হচ্ছে সেই নাম্বারটা ইন্ডিকেট করবে যে ওই সিস্টেমের কতগুলি পোল রাইট হাফ প্লেনে রয়েছে এবং সিস্টেমটি আনস্টেবল হবে। Now what is the necessary but not sufficient conditions for stability? We can say that a system may be stable if all the coefficients of the characteristics equation should have the same sign and there should be no missing term. তাহলে আমরা কোনো একটি সিস্টেমের ক্যারেক্টারিস্টিক্স ইকুয়েশনে যতগুলি কোএফিসিয়েন্ট থাকবে, সেই প্রত্যেকটি কোএফিসিয়েন্ট যদি সেম সাইনের হয় এবং প্রত্যেকটি কোএফিসিয়েন্টই যদি সেখানে প্রেজেন্ট থাকে, তাহলে আমরা বলতে পারবো সিস্টেমটা স্টেবল হতেও পারে। ডেফিনেটলি বলা যাবে না যে সিস্টেমটা স্টেবল, কিন্তু এই দুটি কন্ডিশনের কোনো একটি যদি মিট না করে, তাহলেই কিন্তু আমরা বলতে পারবো যে সিস্টেমটি আনস্টেবল। এখানে দুটি এক্সাম্পলস আছে। ফার্স্ট এক্সাম্পল, s to the power 4 plus 3s square plus 2s plus 1 equals to 0. This system is unstable because there is no sq term. And in the second example, 4sq minus s square plus s plus 7 is equals to 0. This system also unstable because here the coefficient of sq, s and s to the power 0, these are positive, but the coefficient of s square, that is minus 1, this is negative. So this system is unstable. Now there are some examples. for checking stability. The first example, the characteristics equation is S4 plus SQ plus 2S square plus 4S plus 1 equals to 0. Now we can compare it with general form of equation, that is A4 S to the power 4 plus AQ SQ plus A2 S square plus A1S plus A0 equals to 0. So A4 is equals to 1, A3 is equals to 1, A2 equals to 2, A1 is equals to 4 and A0 is equals to 1. Now what is the how we can form this table? Firstly, we have to write down the highest order of S to S to the power 0, that is S to the power 4, SQ, S square, S to the power 1 and S to the power 0. Now in this first row we have to put the coefficients of A4, then A2, then A0, that is 1, 2 and 1. In the second row we have to put the coefficient of S3 and S, so that is 1 and 4. Now we have to calculate the remaining part. How can we complete the remaining part? In this case there is a cross multiplication procedure. So here A3 into A2 minus A1 into A4 divided by A3. So 1 into 2 minus 4 into 1 divided by 1, that is minus 2. Here A3 into A0 minus A4 into, there is nothing, so 0 divided by A3, that is A3 into A0 by A3, that is A0, that is in our case that is 1. Now at this point minus 2 into 4 minus 1 into 1 divided by minus 2, that is 9 by 2, and in this case here 9 by 2 into 1 minus minus 2 into this one is 0 divided by 9 by 2, that is 1. So we can see in this first column the first root is 1, then minus 2, then 1. So there is two sign changes. Firstly, this SQ to S square, that is 1 to minus 2, and secondly minus 2 to 9 by 2. So we can say the system is unstable and has two poles in right half plane. This is the second example. S to the power 4 plus 8 SQ plus 18 S square plus 16S plus 2 equals to 0. So we can write S to the power 4 to S0 in here, and here we have to write the coefficient of S to the power 4, then coefficient of S square, then coefficient of S to the power 0, that is 1, 18 and 2. And in this row we have to put coefficient of SQ, then coefficient of S, that is 8 and 16. Now here we we have to calculate previously the cross multiplication has to be done. 8 into 18, that is 8 into 18 minus 1 into 16 divided by 8, that is 16. Here 8 into 2 divided by 8, that is 2, because this part is 0, so 1 into 0 will become 0. Here 16 into 16 minus 8 into 2 divided by 16, that is 15, and here 15 into 2 divided by 15, that is 2. So we can see that there is no sign change and system is stable. There is another example, and we can see that the system is unstable and two right hand sided poles for this characteristic equation or for this system. You can calculate yourselves. Now this one is another example where a closed loop system, unity feedback system and negative unity feedback system. So g of s is equals to 1 by s square plus 3s plus 1 and h of s equals to 1. Now the characteristics equation, we know the characteristics equation equals to 1 plus gs into hs. So we can determine the characteristics equation as s square plus 3s plus 2. You can also determine the closed loop transfer function, from that you can determine the characteristics equation, that is same 1 by the transfer function is 1 by s square plus 3s plus 2, and the characteristics equation is s square plus 3s plus 2. Now here the highest power is 2, second order system, so we have to write s square s then s0, and here we have to put the coefficients of s square and s0, that is 1 and 2, and here 3, the coefficient of s. Now we have to calculate this part 3 into 2 minus 1 into 0 divided by 3, that is we get 2. So we can see in first column the roots are 1, 3 and 2, so all roots are positive, no sign changes, and system is stable. Thank you.